So, in order for you to really understand this journey, there are a few things that I want you to know about me. One, I was born and raised in New York City. I'm from the borough of Queens, which is the most diverse of the 5 boroughs in New York City. And for me, that diversity really began at home. This is a picture of me. I'm about 2 or 3 years old. Very fashion forward, right? Some things just don't change. Um, and I like this picture of me because I'm wearing a shirt with the Puerto Rican coquis and the tree frogs, and the shirt says Puerto Rico. So for me, that diversity began with my mom and my Puerto Rican stepdad who raised me. And then here's a picture of me with my poppy at my sweet 16. And when I think about family, it's not just my mom and my poppy, right? It's my maternal grandmother and aunts and uncles and cousins that I grew up with and that heavily influenced me. And so this is a whole host of family members at a get-together a couple years ago. So collectively, my family instilled certain values in me. One was education. So my parents stressed education, and my mom, my aunts, and my grandmother were all educators in the New York City K-8 public school system. So I have this quote here by civil rights activist Marian Wright Edelman, that education is for improving the lives of others and leaving your community and world better than you found it. I also was introduced to living a life of service. And if you've ever received an email from me, you may notice this quote by Dr. King at the bottom of my email signature. It says, "Life's most persistent and urgent question is, what are you doing for others?" And this has been one of my anchoring quotes, and it has allowed me to see everything that I do through a lens of service. And then lastly, my family raised me with the Christian faith. So I have the scripture from Proverbs 22:6. "Train up a child in the way he should go, and when he's old, he will not depart from it." So how exactly did I become an engineer? One of the readings that we had this summer was by Lee Hardy on work, life, and vocational choice. And in thinking about how you should approach vocation, he posits 3 questions. First one, what are the abilities and talents that God has given you? The second one, where can your native abilities and acquired skills be put to the disposal of those who need them? And thirdly, it's not just about having a Christian attitude about the work that you're doing, it's also evaluating the social content of the work that you're doing. And in particular, there are 3 more questions with respect to that. Are you making a positive contribution to the human community? Are you helping to meet legitimate human needs? And are you enhancing what is true, noble, and worthy in human life? So I want to walk you through these 3 questions, and know that I'm giving you a very polished version of my journey. It really took a lot of reflection, looking back at everything that I did to come to these questions. So please don't think that my path was linear. It was definitely very convoluted. So the first thing that I want to talk about, that first question, right? What are your God-given talents and abilities? So here, I want to talk about my spiritual gifts. My 2 dominant gifts are mercy, so being able to help those who are in distress, whether it's physical or emotional. And my second dominant gift is shepherding, which is also sometimes called pastoring or pastor-teacher. So it's really about overseeing the development of others and helping them grow. And then when I came to Hope, and I did my strengths finders, right, I found that my top 5 strengths were mostly in the executing, relationship building, and strategic thinking domains. So for executing, I'm restorative. I like to solve problems. I have quite a few strengths in relationship building. One is connectedness, right? I can find the relationships between those seemingly random things, and I believe that everything happens for a reason. I'm also a developer, so I like to see the potential in others and take them from where they are and help them to get to where they want to be. I also have the strength of harmony, so being very collaborative and being the glue to hold things together. And for strategic thinking, I'm a learner. I like learning new things, thinking about new ideas and ways to see things. And when I put that all together, we look at Ephesians 4:12, right? We know that when we are operating in our spiritual gifts, and I would even take that further and say operating in our strengths with those gifts, right? We've been equipped by God for the work of his ministry and to build up the body of Christ. So the second question that Hardy has to do with your abilities. And I remember growing up in the church, quite often I would hear this expression, God doesn't call the qualified, he qualifies the called. And Hardy expands on this a little bit more. Now, I won't read the full quote, but I will paraphrase that typically we do the things that we are qualified to do, and we don't do those things that we're not qualified to do. But when we think about certain people in the Bible, like Moses, who had a stutter, yet was called to be a leader of people and to go speak before Pharaoh. Or we think about Jonah, who was sent to Nineveh, which is the last place he wanted to go, that we need to remain open for God to use us in these ways, to do these things that we may not really want to do, or to do things that we may seemingly be unqualified to do. And it's in those instances that God is going to use his power through us, right, to do something miraculous. So for me, being an engineer, I liked math. Science was okay, but I wasn't that stereotype of the kid that took the remote or other appliances apart and put it back together. That wasn't me at all. So I remember that there was a very popular medical drama on TV at the time, and I thought that I wanted to be a doctor. And I watched a few episodes of that show that were a little gory, and I realized I was squeamish, and medical school was not for me. And so I had been exposed to engineering as a middle schooler, and when I started looking at college view books, I looked at what the engineering programs had to offer. And when I came across biomedical engineering, seeing how people were working on artificial organs and tissues and developing different types of drug therapies, I said, ooh, I can work with doctors, I can help people, and I don't have to see blood and guts. Sign me up. And so for me, even though I didn't fit that stereotypical idea of what an engineer was or looks like, I went through this process of calling and qualification because I felt this pull towards engineering, particularly biomedical, and I couldn't quite explain it. But through all of my education and training, God has showed me that this is what I'm supposed to be doing. So I want to talk about Hardy's third question, right? That social content of the work that you do. And so I want to introduce another article that I read by Brad Kallenberg talking about the theological origins of engineering. So he traces engineering back to ancient times when it was referred to something as mechanical arts. And it was mostly things like work that blacksmiths would do. So he says that mechanical arts allow us to understand the humanity that God has created and respond to Jesus' redemption of living in a fallen world. And that with mechanical arts, the products that we develop are to alleviate physical weakness. And also through this process of mechanical reasoning, this is how we can journey towards a reunion with God. And so when I think about what biomedical engineers do, we are the ones that work towards alleviating physical weakness. We come up with therapies for diseases. We come up with prosthetic devices. We understand movement. There's a lot of problems in medicine, and it's up to biomedical engineers to come up with solutions to solve them. So we build up the body in a physical sense. And what I really appreciate from a theological perspective is that we can experience this redemption with God through healing. And we see these connections with Jesus' ministry of healing, particularly as it's documented by Luke, who himself was a physician. So no, I'm not saying that biomedical engineers are Jesus, or that we're trying to do anything to the level of Jesus. But it's this idea that the work that we do, it allows us to participate in the mechanical arts, and it allows us to have this connection to God and meet these human needs. So I went to the University of Pittsburgh, and I found my specialization in biomechanics. So initially when I went to Pitt, I was going to study artificial organs and tissues, which was the rage in biomedical engineering at the time. But there were two formative experiences that put me on the path to biomechanics. One was studying abroad at Tec de Monterrey in Monterrey, Mexico. So because of my upbringing, I wanted to be bilingual. And so I had this opportunity to study abroad. And while I was there, I had an internship. So I worked with the sports medicine doctor and sat in on some of his consultations. I worked in the fitness center to train people how to use the equipment, all in Spanish. And I also observed different athletic training courses, including youth swimming and women's boxing. So when I got back to Pitt, I said, I'm really interested in movement. And I switched to biomechanics. And I had an opportunity to do undergraduate research. And I worked with a professor who was doing biomechanics, but merged with this area of rehabilitation. And so that helped me to find my niche. And it allowed me to connect my spiritual gifts of mercy with my strengths of being a learner and restoration. And it also provided me with training for graduate school, because from there, I was able to do a summer research experience at the University of Michigan, where I got to work with kinesiologists. And I also got to do poster competitions. So this is me. I had just graduated from Pitt, and I am at the Society of Hispanic Professional Engineers conference in Denver, Colorado, in the undergraduate poster competition, where I tied for third. So I said, hey, I think this research thing, right, there's something here for me with this. So to go further to Hardy's point about that social content of what we do, I want to talk a little bit about biomechanics. So biomechanics is basically just studying forces that are applied to the body, right? So these forces applied to the body, they cause movement. And so meeting the needs, meeting human needs through biomechanics, we can explore this idea of the redemption of God as his image bearers. And so if we think about our bodies and how we're designed, right? We're fearfully and wonderfully made, and our bodies are designed for movement. And so as biomechanists, right, we study movement, and we study ways to restore movement when there's been some sort of injury, or how do we make movement more efficient for people. It also allows us to engage in restoration and divine wisdom with the approaches that we use. So again, this idea of alleviating physical weakness, that's a consequence of living in a fallen world. When I think of that as a biomechanist, I think of these forces or loads that are applied to the body. And in a biblical sense, right, I think of burdens, right, how we are supposed to give our burdens to God. Well, biomechanists remove those burdens, right, that hinder movement. And it's a very collaborative field because it allows for perspectives from engineers, from kinesiologists and movement scientists, from athletic trainers and clinicians. So when I went to graduate school, I got more training in rehabilitation. So I went from studying how people how they get in and out of their wheelchairs, to looking at children with orthopedic disabilities and using adaptable video game platforms to help them augment their movement therapy. For my PhD, I made a model of the shoulder to understand what happens in manual wheelchair users and the secondary injuries that they experience as a result of propelling their wheelchairs. And it wasn't just the research focus that I had. I also had an opportunity to get some teaching experience. I served as an NSF GK-12 fellow at a local all-girls high school where I worked with a math teacher developing lesson plans with her and being able to teach some of those lessons. And I also worked at the W.E.B. Du Bois Scholars Institute, which is housed at Princeton University. And I got to teach high-achieving middle schoolers of color in courses that I was able to design in mathematical reasoning and mathematical logic. And then I went on to a postdoc because I really liked research and I wanted to keep learning. So that brought me to Case Western Reserve University in Cleveland, Ohio. And our research lab was physically located in the Veterans Affairs Hospital. And so the work that I was doing there was working with implanted nerve stimulation devices. And in particular, I was looking, so I went from keeping people in their wheelchairs, right, to getting them out their wheelchairs. And I looked at standing balance with these systems. So working with the control systems and biomechanically looking at people's posture and seeing how our controllers worked. So that was my main project. And then I got involved in some side projects that brought me back to my work in transfers, so going from one surface to another, where sometimes you can do it independently, right, with the electrical stimulation system, right? So you can get from one surface to another, as this gentleman is going from a low couch to his wheelchair, which is higher up. Or sometimes even with the stimulation, maybe you're transferring to a surface that's just too high. Or maybe your level of spinal cord injury is too high where you can't do things independently. So we looked at assisted transfers, and particularly the lifting portion, because that's where the most injuries happen. And I still had more opportunities to teach. This time, Du Bois invited me back for a new school year program that they started, and I got to lead the engineering division, and I got to write and teach the curriculum. And so this was a workshop that I did with a colleague of mine teaching students about lower limb prostheses. And we gave them this design challenge where they had random objects and they had to make lower limb prostheses and test them. So here's a couple of their prototypes. I want to go back to Hardy's idea of staying open to God, using you in different ways. Because once my postdoc came to an end and I started thinking about the next step, I had a few ideas, and I really wanted to cast a wide net because I didn't really know what God wanted me to do next. So I applied for some opportunities that would keep me where I was at Case, so doing an internal career development grant, and then also a pilot project that I would continue in that transfers work. And then I just went on the job market. I liked teaching. I liked mentoring the undergraduates that I got to work with in the lab. So I thought, well, maybe I can become a professor and not focus so much on like a research professor path that I would had I been in the research group in Cleveland. And then, you know, because when we stay open, sometimes there's a plot twist, which brought me to Hope. So my now colleague and department chair, Katie Polasic, did her training, her PhD training and her postdoc at Case Western. And I happened to meet her at a conference, and she was telling me how she has been at Hope and she started the biomedical engineering concentration. And I said, well, what's a liberal arts institution? What does that look like working with undergraduates? And I came, I gave a seminar talk, and the next thing I know, I'm hearing from Dr. Van Wylen, who was the dean at the time, and he told me about a faculty fellowship program that they had at Hope. So I came in 2019 to Hope as a fellow, and that allowed me to get teaching experience and also start engaging undergraduates in independent research. So I want to fast forward 4 years later. I'm here, still here at Hope. Now I'm on the tenure track, And I want to just give you a snapshot of how I use my different gifts and strengths with my different roles here at Hope. So with teaching, right, sometimes it's doing some outside of the box things, like using candy to teach my engineering computing students about how loops work in computer programs. Sometimes it's collaborating with colleagues. So one of the criticisms of engineering that Kallenberg brings up is that engineering also has these origins with foot soldiers. And soldiers just do what they're commanded to do. And when we think of this in an engineering context, the question is, well, where does ethics come in for engineers? If they're just doing what they're told, how are they supposed to understand ethics and the decisions that they make? So I teamed up with Kate Finley in philosophy, Rodrigo Serrao in sociology and social work, and Tori Longfield in the library to create this collaborative module for my engineering computing class on ethics and social responsibilities of engineers. And we took that work and turned it into a couple of conference papers for the American Society of Engineering Education. And most recently, we just submitted a textbook chapter for a textbook on mitigating bias in machine learning. Sometimes it's taking those outside of the box ideas to other departments. Like last spring, I see my friends from kinesiology are here. When I taught the biomechanics course in the lab, our very first lab, we were talking about concussion biomechanics. So as an engineer, what do? I have the students do an egg drop, but not just any egg drop. They had to make a helmet for their little egg athlete, and they had to keep their little egg athlete from cracking its head open. So this is one of the examples of one of those helmets. With teaching, sometimes it also blends with mentoring. And so for our senior design students, or capstone if you will, I get the opportunity to mentor students that are doing rehabilitation-focused projects, like this group that was working on a bike for someone who was a manual wheelchair user. And then in terms of institutional service, Andy mentioned some of the work that I do with my colleague, Dr. Goach, at Keppel House. For professional service, I'm very active in the main society for my discipline, the American Society of Biomechanics. And in particular, I'm very active in our affinity groups. One in particular is the Black Biomechanists Association, where I co-lead our mentoring subcommittee. And we work very closely with the Latinx and Biomechanics affinity group, which I'm also a part of. And then for community service, I happened to meet a prospective student who goes to Holland Christian and is interested in biomedical engineering. And she's been doing these workshops on engineering and STEM fields at the Herrick Library. And she asked me to be a guest speaker for her workshop that she had last month, where she was teaching students how to make a prosthetic hand. And so I have just little screenshots of the flyers, because one is in English and the other one is in Spanish. So I didn't make the flyers, but when I shared them on social media, I did do my post in English and Spanish. So I am still looking for ways to be bilingual. And lastly, where I want to just spend a little bit more time is talking about the research that I do now that I'm here at Hope. And so I want to talk about my research group, where we focus on more biomechanics and engineering approaches, and lately some collaborative work that I've been doing with Fola Olabemi and computer science. So this is me with my group from the summer and her with her group from the summer. In particular, I want to talk about a project that we just started that's been funded by the Restore Center at Stanford. So if we go back to that work that I was doing when I was in Cleveland on assisted transfers, I decided to look at patient handling tasks in general, right? So going beyond assisting someone with a transfer, looking at tasks like turning someone, pivoting someone, the pushing, the pulling. All of these collectively are patient handling tasks, and they're done in really awkward postures And oftentimes in tight spaces, as you can see from this image here of using a pivot maneuver to get someone, to transfer someone. And when I started looking at the literature, I noticed that in particular in the allied health fields for nurses and nursing assistants, that the risk of injury is very high, not only for new nurses, but over the career of a nurse. Well, it just so happens that we have a nursing department here, and I see Melissa. And when we look at the literature for nursing students, some of the more recent work shows that there's a difference in the performance of these tasks if you compare a student to someone who's a little bit more established in the field. Students have a 50-50 chance to replicate what they are taught to do. And it's believed that, that it's because a lot of the techniques that they learn are passive. So learning from a video or watching someone do it. And when you look at the literature and they talk about performing tasks with good posture or bad posture, there's no standard definition for these. And when you look at the papers, right, everyone's got a different definition. So Fola and I came together and we got this idea that, well, one, you don't just have good posture and all of a sudden, oh, you broke your back, right? There's got to be some window in between that's probably neutral. May not be the best pose for you to be in, but you may not hurt yourself. And we wanted to come up with a way, how can we classify performance? How can we give students feedback on how they're performing so that when they go out into the workforce, they can be less likely to injure themselves? So with this summer, my students looked at a couple of different tasks that we simulated in the lab. So we use mannequins instead of actual people because real people can help, and then that's something else that you have to factor into your equations biomechanically. So we use mannequins, and also that's how students are trained. They use mannequins. It's not until they're out at clinicals where they're interacting with actual people. So we looked at sitting someone up, turning someone on their side, lifting up a patient's leg. We looked at lifting them from a wheelchair, placing a sling under a patient, which is often done with at least two nurses, or using slide sheets to adjust someone in the bed, which is also often done with two people. So my group focused on biomechanics. So one thing we started looking at was, well, can we find windows for what we're considering good and poor posture? And can we find this window of neutral? Like, is this really a thing? I had another student that looked at the role of trunk rotation. Normally, it's trunk flexion, right? This is what is commonly looked at in the literature. And my student said, well, some of the tasks that we do, especially the sliding tasks, they're asymmetric, so your hands are doing different things, and your trunk is rotating. So she started looking into trunk rotation, and it turns out that that's something important that we should look at. And then I had another student that was looking at joint angles and height, right? How do people of different heights perform these tasks? Turns out very differently depending on your height. And then Fola's group, they brought in machine learning to enhance what we're doing biomechanically. So one, that's where the classifier comes in, right? Taking this idea of the different joint angles during the task performance, the different ways that the tasks are being performed. And then we also use 3 different types of mannequins. So a 44-pound one, a 66-pound one, and then a 110-pound one. So as the weight increases, does your performance change? And how can we classify your performance? And then she also started looking into explainability. So we all know machine learning, right? It's a black box. How does it make those decisions that it makes? And so she has a funded project where she applied some of this data to see how is it that the classifier is picking the particular features that it picks. And so the work that we did this summer was with students that were not nursing students, just for us to get proof of concept. We just got HSRB approval, so we are recruiting. So if you know any nursing students, please send them my way. And just to touch on the current work and future directions. I want to continue my collaborations with nursing, kinesiology, and computer science. And so some of the ways that I see that, I have a student who is working on sensor-based approaches for training. So we're looking at, can we provide vibration when people are performing tasks to give them feedback about their posture? So if you're in a poor posture and you feel this vibration to let you know you're in a poor posture, you can readjust, right? And put yourself at a lower risk of injuring yourself. Going back to mentoring, I serve as a mentor for the nursing research practicum course, and I get to work with nursing students, so not only as research participants, but partnering with them to help with the research. So they try out some of the technology that we have, but they work with us on the research. We do some survey collections during our biomechanical testing of how comfortable and how safe students feel performing these different tasks. And we look at the perceived stresses and effort required to perform these tasks. And so that's what the nursing students have been working on. And it's been great for my students to have that interdisciplinary training. I already talked to you about classifying posture, and I want to look into a little bit more about training methods. And where I see this work going, I know I'm doing a lot with students. I would like to get to nurses that are in the workforce and get back to what I started when I was at Case, working with lay caregivers, so family members that aren't necessarily trained in these techniques at all. I think about my mom, who has become my grandmother's primary caregiver, and my grandmother needs assistance sometimes getting in and out of the bed. My mom hurt her shoulder, trying to help my grandmother. So we know that this is a very important problem to work towards. And I've been focusing a lot at the low back, but as I just alluded to with my mom, the shoulder and the neck region is the second most area of the body in the musculoskeletal system that's injured. And so that's where I see myself going over my time here at Hope. And so what I've learned, just by being able to be open and accept that faculty fellowship offer, that I'm exactly where I need to be right now. So again, I gave you a very polished version of my journey, letting you know my strengths and gifts ahead of time and not exactly when I found them. So I just want to say that a lot of times I was kind of like, God, am I hearing you right? Should I be doing this thing that seems very different? Or even at times kind of, a random thing for me to be doing. Why am I taking time away from my research to do this teaching or this outreach? And so what I want to leave you with is this other anchoring quote for me by feminist, poet, and activist Audre Lorde. When I dare to be powerful, to use my strength in the service of my vision, then it becomes less and less important whether I am afraid. Thank you.
Okay, we have several minutes to take questions from you for Dr. Odle. Well, as you think about that, I know I have one. Lindsay's laughing at me back there. Mine is this. When you were working with non-nursing students, right, to think about biomechanical injuries and doing the research, I know that every year I get older, the undergraduates stay the same age. And they have very few biomechanical problems in many cases because they're like 20. Did you have to give them a vision for kind of the research that you were doing, and what did that look like?
Right, so actually, I didn't say this, but in order to train the classifier, we had the students doing all of those tasks with the different mannequins, But we also told them, we tried to standardize a good posture and a poor posture and show them, like, this is how we want you to do this. So for example, the wheelchair, right, we know when you're lifting, you want to lift with your legs, not your back. So we said, okay, right, use your legs more than your back. And then that would be our good posture. And then for poor posture, it would be, okay, now, like, use your chest more than your legs. So we tried to work with some sort of standardization for the purposes of the classifier to know this is how we're saying this is poor posture, this is good posture. Look at these joint angles and these tasks and these weights. Is there a relationship that you're finding between them? So, yeah.
Yeah, I know Dr. Carlson's here, and he noticed me walking last week, and he was like, Andy, it looks like something's wrong, and I had lifted something wrong. Thank goodness for physical therapists.
Yes.
Right? Others.
Yeah, thanks. So you had this kind of interesting time where you went to Tec de Monterrey in Mexico. Can you talk a little bit about that and how that, like, it sounded like that was really instrumental in changing from like tissue to really the biomechanics. Can you talk about that part?
Yes. So that was in an exchange program. So I had a scholarship to study abroad. And actually, the biomedical engineering program there is in the medical school. And so I couldn't get clearance, right, for the short time, the 6 weeks that I would be there. So they worked it out where I worked with the sports medicine doctor. So being able to sit in Spanish, right, listening to the different consultations, seeing how he was treating, different students that came in for different things. And for me, it really spoke to, I guess I would say in my family, I'm the one that's the helper. And I think for me, it really connected with, that gift of mercy, but also I want to help people. And I liked medicine. I was very curious about healing and, injuries. And so being able to see that, to go observe those classes and look at the different movements and start thinking about how our muscles are allowing us to do these different types of movements. Working in the fitness center, and I will say, this is the funny thing about working in the fitness center. My shift was like early in the morning, so I was trained to teach people like how to like go through the campus fitness program, but no one joins the gym at like 7 a.m., so really my internship was just working out. Which is fine for me. But again, right, I really had this opportunity to think about how do we treat people, right? How do we try to figure out medical problems, right? So that restorative strength. But then also, right, thinking about movement in all of these different ways, right? How does it allow us to do these different tasks, like swimming versus boxing, right? You're using your muscles in different ways, right? Working in the fitness center, the different cardio and strength machines, right? Again, using your muscles in different ways. And so it got me thinking, about movement. And that's what, I really found myself more excited about. And so that's why when I got back to Pitt, I was like, all right, biomechanics, sign me up.
Maybe this is more on the personal side, Brooke, but you have experiences living in New York City, Pittsburgh, Cleveland. These are big cities, and now Holland. Thoughts about like you as a person being here in the Hope College community.
Yeah. So I think that I can bring a perspective to students. Particularly, I recently met with a student of color who's asked me, how did you navigate being at a predominantly white institution? So I think I can come in and bring that perspective for students, and I'm pretty sure for a lot of the engineering students, I'm probably their first professor of color that they have. One of the things that I have, come to know through volunteering with CDI, right, I'm learning about a lot of the local organizations like LAUP and IM Academy, and finding ways to connect with them and find those things that I need personally, right, to form community. And I've got amazing friends here, right, started as colleagues and have become very good friends. So I've been able to just find community for all of the different things that I need in my life.
Anybody else? Okay, well, I want to thank you for attending with us today. And I want to take one more time to tell Brooke, it is such a joy to be your colleague. I'm so glad for the people, not least of all Dr. Van Wylen there, and all of those who brought you, even through a plot twist, to us. So thank you for joining us today. Let's thank Dr. Brooke Odle again.
Thank you.